So what we did as a neat experiment, kind of really showcasing the capability of using this advanced technology. And the objective here was within like 10 minutes, we wanted to be able to drop the robot in the water, have it figure out where it is relative to the map that it had built in May, and then drive back to an interesting feature that we had identified in the hull from our May experiments. What we're trying to do is develop robotic systems that are able to autonomously map ship hulls while they're in port for the specific problem of limpet mines. This is something that traditionally you would do by using human divers, but it can be a dangerous and complex environment for a human to be in, especially if we're talking about limpet mines that might be placed on the hull. And so the idea is how you can remove the human from being at risk by having a robotic system do this. So by equipping the robot with these camera systems, what we're able to do is essentially allow the robot to navigate much more like you or I do as a human, in the sense that it can use visual information to recognize places on the ship hull that it's seen before. So what we did is we deployed the robot in May of this year on the USS Saratoga, which is a decommissioned aircraft carrier. Using our algorithms, we're able to basically build this high fidelity kind of three-dimensional map that represents kind of the below water portion of the ship hull. And then several months later, in August, we dropped the robot back in the water, and immediately like, oh, hey, I recognize I've been in this hole before. I know exactly where I am, and it was able to snap itself back into that map, and then immediately drive back to an interesting feature on the hull. One of the kind of cool things about the technology we've been developing is that if you really wanted to map a hull fast, the way you would do it is not with a single robot, but with multiple robots all at the same time. So I think ultimately the future application of this for the Navy would be not just a single robot that is being used to map a ship, but probably teams of robots all working collectively together to do this. The real kind of growth area for this is commercial applications of this. How do we assess the quality of the hull? Is there any damage to the ship? Is there any bio growth on the ship? There's a lot of growth area for that in terms of the commercial applications of this that will outgrow from the Navy's specific needs of us trying to do the kind of limpet mine detection on the hull.